Alright everybody, so this is the second video that supports the Trig Identities 1 booklet. And here we're going to start using our trig identities in equations. But before I get started on that, I want to bring this up. And I'm going to hold it here so that you guys can scroll back to the front of the video and have a look at these particular trig identities. Because we're going to be using these trig identities in our questions. So let's talk a little bit about these 6 algebra triangles down here and how I was able to come up with those. They come from these two things here. So I'm going to go through each of those triangles individually, and then we're going to start applying our trig identities to trig algebra problems. So let's get started there. Alright, so we've proven in the last lesson that tan theta is sine over cos, and we've proven that cotangent theta is cos over sine. So to write these out as algebra triangles is not a huge deal, right? So we want to think of tangent as is able to be divided, or is equal to sine divided by cosine. So tangent would go in one of the bottom spots, and sine on top and cosine on the bottom. So let's write that out. So pause the video and see if you can write out the algebra triangle for this one. Okay, so cotangent, well that's the same as the tangent, that goes in one of the two bottom spots, right? So I'll put cotangent here. And it's cos over sine, so cos over sine. And we're allowed to make, we can make 3 different formulas out of this. I can have a formula for sine, so sine is tangent times cos. So sine theta, theta is equal to tangent theta times cos theta. Or if I want cosine is sine divided by tangent. Or sine is equal to cos divided by cotangent. Or cos, so I could say that sine is equal to cos over cotangent. Cos theta, we'll put the thetas in there, over cotangent theta. So I can make, well, for each triangle, I can make 3 different formulas, right? I can make tangent is sine over cos, sine is tangent times cos, or I could do cosine is sine divided by tangent, right? Cos theta is sine theta divided by tangent theta. So these algebra triangles are like really, really handy in using them to help us break the codes of some of these questions that you're dealing with. And that's why I showed them to you at the beginning of the class. So if you haven't written them down, then scroll back to the beginning of the class, write them down, and then come back to like 3:15 and get ready for the next part of the lesson. Okay, so I want to make the next 2 algebra triangles, and what I'm going to do is I'm going to take tangent is equal to sine over cos and rewrite it as sine times 1 over cos, because if you multiply those 2 fractions and sine over 1, then I get this over here. So I do the same job over here. And I have a knowledge of what 1 over cos is. 1 over cos, if you remember from your algebra stuff, that's equal to secant. So I can rewrite this as tangent theta is equal to sine theta times secant theta, right? This is secant theta, 1 over cos. So now I can write this as an algebra triangle. See if you can write it out. Right, so tangent is sine times secant, right? That's what that looks like down below. So I can also find that sine is tangent divided by secant, or secant is tangent divided by sine, right? I can create 3 separate equations from that piece of information. So let's see if you can do the algebra triangle for this guy right here. Remember, 1 over sine is cosecant. So pause your video, see if you can do it on a scrap sheet of paper. I'll post it in a moment. Okay, so that's what I got right there. So let's do our last 2. Okay, and see what we can make from those. Okay, so let's start off with these two items from our last set of triangles. And let's rewrite sine as its reciprocal and cosine is its reciprocal. Right? Sine is the reciprocal of cosecant, and cosine is the reciprocal of secant. So let's rewrite those two in terms of their reciprocals. Have a look. Okay, so sine is the same as the reciprocal of cosecant, right? That's from a previous lesson, and cosine is the reciprocal of 1 over secant. So those are from like a few lessons ago. You've been using them fairly frequently, especially in the algebra section of the course. So this is just kind of a little bit of review of that. And now let's rewrite this part over here as a fraction, and do it to the other side. Okay, so there we go, right? I'm just joining, putting the cosecant on the bottom and the secant on top, right? I hope that's not anything that's too complicated. If it is, right, we just write these as fractions over 1, and then we just multiply fractions, and we're just multiplying by 1, so we just join them as a simple fraction. So now write out their triangles. See if you can write out their triangles from this point here. Okay, you got 2 of them to do. See if you can do it. Okay, so there you go, and that takes us to our last set of triangles. There's really 6 algebra triangles total. So if you think about it, there's 6 algebra triangles. Each of those triangles has 3 equations that you can create from them. So there's 18 separate trig identities that you can access at any time. And then you have your Pythagorean ones, with the squares in them. And you can move those guys around too. We've proven that those are true. So the rules of algebra will follow because they've been proven to be true. But some of the stuff we haven't proven yet, and so we'll get to that in the next week's set of work. So for right now, what I want to do is I want to look at some algebra equations that use trig identities to, to solve them. So we'll have a look at a couple of those. Okay, so here's a question from your booklet, very similar. I'm just using thetas instead of x's, but on page 3, number 1, I ask you to solve this. And if you didn't know that sine divided by cosine was tangent, because if you look on one of your triangles, it's one of our main ones that we've been learning from, you would probably be quite stumped. But let's just contemplate how we would approach this question. So our first job is to convert to a single trig ratio, and we should know that sine theta divided by cos theta is tangent theta. We have a triangle that we've got that does that. You can scroll back to the beginning of the lesson and you can see it, and you've been doing them yourselves. Tangent is sine over cos. You want to look to find the triangle that has sine on top and cos on the bottom. That's the very first one. And it lets you know that that can be simplified into tangent. So we just rewrite the equation with this part the same as tangent. Right? We've already kind of proved that a bunch. Okay, and so now we can solve it very, very quickly and easily, right? Divide by 2, inverse tangent, CAS rule, yada, yada, yada. See if you can get the answer. Make sure your calculator's in degree mode. A lot of people forget that. Okay, so these are my 2 values from the CAS rule. I'm missing something. Anybody remember what it is? Yep. Plus 360n, and yeah, don't forget when you're doing that, when you're doing algebra. Right? There's an infinite set of answers, right? I can go around the circle an infinite set of times, and so that's our coterminal statement. I'll be looking for it in the algebra section when I'm marking your work, so don't forget, right? Those are important details to remember. Okay, so they get harder from here on in, and then I can have multiple layers of disguises, and all I'm really doing is I'm creating disguises for a single ratio, like a tangent or a sine or something like that. So let me see if I can dream up something pretty nasty and see if you guys can get it. Check it out. Alright, so this is the kind of question that I would be putting on test for algebra using trig identities. And at first glance, I mean, that looks pretty harsh. I mean, you got 1, 2, 3, 4, 5 thetas going on. And like, how do you manage all that? Well, again, it's about finding the disguise inside these expressions and try to break it down into a single type of expression. So let's go through some of those things. Look on your sheet, or go scroll back to the beginning and come back to 940 and tell me what tangent squared theta plus 1 is equal to. Okay, take a moment to do that, and I'll do it on my whiteboard here. Alright, so tangent squared theta plus 1 is equal to secant squared theta. Alright, what about tangent divided by sine? Look on your triangles. see if you can find one that has a tangent on top and a sine as one of the bottom parts. Can you find that? What is that equal to? Okay, so on this side over here, this top part is secant squared and the bottom part is secant. So that's like x squared divided by x. Right? This is just like a 1. So it's like saying x squared divided by x. When I divide those two, I'm just left with one of them. So this all turns out to be equal to secant theta on the bottom. So all this fancy stuff up here is just that. So I've disguised this in this manner. And I've also made a disguise over here. Can you find from one of your Pythagorean identities what sine squared plus cos squared is equal to? Make that change on the other side of the equal sign. See what you get. That's right. Sine squared plus cos squared is equal to 1. So this is just 3 times 1, which is just 3. So now you have a very easy question to solve, right? Secant theta is equal to 3. Okay, so let's see if you can solve it and get the right answer. I'll show the work over there. Right, so secant is the same as 1 over cos. So I got to flip both fractions, get cos on top and flip the other fraction. Remember that trick? Okay, so there's my reference angle. Theta 1, well that's because cos is in the first quadrant and in the fourth quadrant, so my last one is there. And don't forget the coterminal statement. There you be. Okay, so that booklet that I've assigned you, right, or that set of exercises to do, is to help you get to this particular point. Right, we start thinking about the structure of our primary identities and our secondary identities. I get you to fill out the algebra triangles. You start finding disguises, and so that takes up a couple of pages. And then on the last page, you start dealing with algebra. This type of algebra, which looks daunting until you realize that it's actually just a bunch of disguises that you have to unmask. So are you a detective? Are you sharp enough? We'll see. So that's it for me for this week, and hopefully we'll be able to carry this on next week. Okay, take care, guys. See you later.